Multiplying and dividing rational expressions. First of all, the steps for multiplying rationals. We begin by simplifying as much as we possibly can first. So we simplify each rational by factoring each numerator and denominator, but then we can cross cancel, which means any numerator and denominator that has a common factor, we can cancel out that factor. And then we multiply the remaining rationals together. So example 1, look at the problem. Notice it's simply an expression, no equal sign, so we're just simplifying. And what we're being asked to do is multiply these two rationals together. So begin by factoring the first numerator. It's going to factor into x plus 12 times x minus 12. Its denominator factors into x minus 9 times x minus 7. Do the same thing for the second rational. The numerator factors into x minus 9 times x plus 2. Its denominator x plus 12 times x minus 4. So now it's just a matter of cross-canceling. Since we cannot simplify each factor, we have an x plus 12 in the first numerator. It's going to cancel out with an x plus 12 in the second denominator. Same thing as the x minus 9s. As long as the factors in the numerator and the denominator, we can cancel out. Now we multiply what's remaining. So we have an x minus 12 times an x plus 2 in the numerator. The denominator x minus 7 times x minus 4. We've combined the two rationals into one, and we can leave our answer in this factored form. There's no point, we're not required to FOIL these binomials back together and put it in the standard form. So at this point, the rational is simplified. Example 2, multiplying two rationals once again. Begin by factoring. The first numerator factors into x minus 11 times x plus 5. Its denominator, we have to begin by putting in standard form. And then we see the leading term is negative, so we factor out a negative or negative 1, leaving us negative 1 times x squared minus 36. So we continue factoring using the difference of squares. The next numerator factors into x minus 6 times x plus 2, and its denominator x plus 5 times x plus 10. Once again, the rationals themselves do not cancel, but we can cross cancel. The x plus 5's cancel, the x minus 6's cancel, leaving us x minus 11 times x plus 2 in the numerator. The denominator x plus 6 times x plus 10, and that negative down there we pull out in front of the rational, so negative x minus 11 times x plus 2 times x plus 6 times x plus 10. Dividing rationals. When we're asked to divide rationals, the first thing we're going to do is change the division problem back into a multiplication problem. And we do that by taking the reciprocal of the rational that immediately follows that division sign. So example 3, notice still no equal sign, just an expression. We're asked to divide these two rationals. So the first rational does not change. But in order to change that division problem into a multiplication problem, we take the reciprocal of that rational that immediately follows it. So the denominator becomes the numerator becomes the denominator. Now it's nothing more than a multiplication problem. So go ahead, continue, factor everything. The first numerator factors into x minus 10 times x plus 8 over x minus 6 times x plus 3 times x plus 3 times x plus 1 over x minus 7 times x minus 10. So the x minus 10's cancel, the x plus 3's cancel, leaving us x plus 8 times x plus 1 all over x minus 6 times x minus 7. And example 4, once again dividing two rationals. We know we're going to change this to a multiplication problem. The first rational does not change, so we're going to factor it into x minus 9 times x plus 3 all over x plus 4 times x minus 1. Take the reciprocal of the second fraction, the denominator becomes the numerator, so we can factor it x minus 7, x minus 1, The denominator, x minus 9 times x minus 9, or x minus 9 squared. So that one x minus 9 in the numerator cancels out with one of those x minus 9's in the denominator, and the x minus 2's cancel, leaving us x plus 3 times x minus 7 over x plus 4 times x minus 9. Completely simplified at this point.